Okay.
So yeah,
we're ready to go. All right.
Awesome. Question 2. Which of the following variables is or are categorical? The number of animals in the local zoo, a randomly selected brand of toothpaste at a convenience store, or age and years of randomly selected vehicles in a parking lot. I'm pretty sure it's just the second one, a randomly selected brand of toothpaste.
I agree.
Yep, that's what I got too.
Okay.
All right. I'll do number 3. The mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their score was 112. Which of the following statements is or are true? 100 is the parameter. That is true.
Yep, that's what I have.
And the bottom one, 112 is a statistic.
Yep.
Okay. Yep, that's what I've got. Actually, I don't know. I got the opposite, actually. Let me just see.
I went and looked it up. Let me see if I can find where it has, which lesson it has it in.
Because I wrote it down that the statistic is the number that describes the sample.
Right.
So I put that as being, and then that the parameter is the number that describes the population.
Yeah, that's correct.
Okay.
So parameter is the number. Hello?
Let's see. Population mean is a parameter.
Oh, hi, Allie. Hold on just. We are. Did you get our invite? Weird. Okay, I'm going to send it again. Let me put you on speakerphone. I'm so glad you called, Allie. How you feeling?
I'm feeling okay. Not too bad today.
Okay.
And I'm using my husband's computer because I don't have the charger to mine anyway. But I'm still connected on Google Hangouts, so I don't know why.
It didn't come through. Okay.
Yeah.
And, okay, ALI _ ELLEFSEN at yahoo.com.
Yes.
Yep, there you are. Okay, there's your little picture. Okay, here goes the invite.
Okay. Weird, I'm not getting anything. Is something wrong? I don't know. I mean, I'm on my husband's computer, but it's set up.
Are you on your email?
Yes, I am.
So you're on that email account?
Sometimes you also have to log into Google Hangouts.
She said she did log into Google Hangouts. Can you let me unplug my speaker so Allie just called on my phone. So she said she's
sorry, I don't know what's going on.
She said she's logged in to Google Hangout on her husband's computer, but yet that invite didn't go through. Any ideas, Heather?
You know, I'm trying to think what, unless, I don't know, if it might have something to do with if on his actual computer you have to be, like, go set up to do Google Hangouts on there. I don't know.
No.
Because remember how at the very beginning we had to go through and set up.
Yes, I bet you're right.
And I don't know if that's by account. It should just be by account, though. It shouldn't be on, like, by computer, right? It should be by your Google account. So
it's Olivia's. Come with Grandma. She presents anything for you. Do you want a snack?
Oh, that's pretty fun. Yes, but I didn't think that was
okay, and we'll find you a snack.
Can you hear her talk?
Yeah, I
of.
can hear her.
Okay. Well,
It's a little bit choppy, but
will this suffice, Allie?
What was that?
Do you think just you being on the phone, and if you have the stuff, you can just talk and I'll hold.
Yeah, I can't hear super well, but I can use my desk.
Okay. I sent an invite to you 3 times, so I'm not sure what else to do.
Grandma has some little grapes for you.
I don't know. I'm so
Do you
sorry.
want some little grapes?
No, that's okay. I wish I was a little more tech savvy to know how to help you. I don't. Are you in, like, did you go to accounts.google.com? Are you on that right now?
I'm on hangouts.google.com.
Okay.
And it has my picture, and it shows all the past conversations we've had.
That's weird. Show that.
That is so weird. Okay, I'm going to try it one more time. Okay, invite people. Send invite. Allie.
So sorry, I know there's so much to go over, and I don't know why it's not working. I'm still not getting anything, so if you don't mind me just hanging out on the phone call.
No, I'm still typing your email address again, so
Oh, okay.
be patient. I'm typing one-handed, so okay, here we go.
Oh, you're fine.
Okay, I sent it. It says up in the top corner, invitation something.
Yeah, I'm just not getting anything.
That is weird. Does it come through on your phone? I can do a Google Hangout on my phone.
Oh, really?
Yeah, but I have Gmail. That's might be the difference.
Oh. Yeah, I have to play it on my phone.
But mine will come through on my phone and on my computer at the same time. So I'll leave this on and we will go forward from here. How's that sound?
Okay.
Okay.
That sounds great. Thanks for working with me.
All right. Do you have your test opened up?
Let me get it opened up right now.
Okay, yeah, go ahead and open it up, and we are only on question 4. And today there's only one question about whether you're meeting with your group. Normally there's 2, but this time there's only 1. So you'll just have to answer question 1, and then question 2 and 3, we'll just go over again.
Okay.
Okay.
Sorry, I'm almost there.
Okay.
Okay, I got it open.
Awesome.
Okay.
Okay, so on number 2,
Number 2, which of the following variables is our categorical? We had a randomly selected brand of toothpaste.
that's what I had.
Excellent. And then on number 3, it was IQ test score. 100.
And these all come right off of our homework,
They
right?
do, yeah, isn't that nice?
Okay.
Okay, so it is 100 is a parameter. Did you understand that, Heather?
hold on, I have a phone call from the hospital really quick.
Oh,
Sorry.
okay, go ahead and take it.
Okay, so Heather's not on the line, but I looked that up to be sure, and it is the parameter is the data for the entire population, and the statistics is the data for the sample.
Right, so 100 is a parameter. That's the one you're
Yeah,
gonna
that's what I
check.
got too.
And then 112 is a statistic. So you check both of those boxes on that one.
Right.
Okay.
Oh, I didn't even notice that.
Yeah.
Okay.
So it's a little different.
Oh, okay. So yeah, check both those and then save it.
Heather has a phone call from the hospital about her daughter. So
Oh,
we're gonna.
okay.
Her daughter actually came home yesterday.
Good.
I know, isn't that good? What a crazy week you and Heather have had, Allie.
I know.
Are you home, Allie?
No, I'm actually not home right now, but
You're not in the hospital, are you?
no, I'm not in the hospital. No, but I'm going in for surgery this Friday morning.
Oh, I thought they did it this last Friday.
They were going to, and because I've gone to Mexico in the last 10 days, they wouldn't let me go into surgery for some reason.
Oh, man.
So yeah, I'm still kind of stuck in the middle, but it's planned for this next Friday.
Oh, good. Okay. Well, we were thinking about you.
Yeah. Oh, thanks.
Okay, while Heather is on her call, shall we discuss number 4?
Sure.
Sure.
Okay. You want to go ahead and take that, Allie? Heather was going to, but why don't you go ahead?
Yeah. Okay, Rockland City has 4 distinct neighborhoods. The property values are very similar, but they vary considerably from neighborhood to neighborhood. Each neighborhood has very low property values, and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of samples should we collect to gauge the residents' responses to a proposed increase in property taxes? And I have a question mark by this one, but I guess a stratified sample. Is that what you guys guessed?
That's what I guessed, but I felt the same way, like it was kind of a guess.
Yeah, I got stratified too, and here was my rationale on that. Let me find my notes.
Yeah, I put stratified as well.
Because
Okay.
it takes a random sample from each section.
Yes.
Mhm.
And a stratified divides the data into similar groups, and then an SRS is taken from it within those groups. So if you had those 4 neighborhoods and they're all different, that automatically puts them into different groups. You would want to take information from each of those groups to get a good sample. So stratified is.
I just always get stratified and cluster mixed up. Because they both seem kind of like the same thing.
Yeah, they both
Like
kind
on
of on groups.
our homework on number 6, the one that was just below that, did you guys put cluster on that one?
I did.
Yeah.
Okay, good.
Yeah.
Well, maybe I'm figuring it out then. Okay.
Which is the next question anyway.
Yeah. Oh, it is? I didn't even notice.
Yep, it is. That's funny.
Okay, Heather, you want to take that one?
Number 5? Sure, I got it. Says when design experiments are conducted in a public school system, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sampling is implemented? And I chose cluster.
I do too.
Yep.
Although,
And the difference is that in a cluster, you take all of the people within the group, whereas in the stratified, you take a random sample of the group. That's how I kind of keep the two.
Oh, that's true.
Because in a cluster, they'll take all within that group, like the different group, but in the stratified, they just take a sample.
Okay.
So that's how I keep the two
That's good.
apart, tell them apart.
although I
Right.
thought that was an interesting, just as an aside, I thought that was an interesting method for a school district because schools can vary within a district so hugely.
Yeah.
So why
Yeah.
would you want to just focus on one school? It seems like a stratified sampling would be much better.
Depends on what, it doesn't really say what they're testing for, so I don't know.
So that's just an aside.
Okay, question 6. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? And I put simple random sample.
Yes.
Yep, that's what I get.
It's funny they have so many of just these questions in our quiz
I know.
out of all that homework.
Number 7, a simple interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100. Then they took a list of registered Republicans and selected a simple random sample of 100. What type of sampling scheme was implemented? This is also a stratified.
That's what I have.
Yep, I agree.
All right. Is it back to me?
Yes.
Okay. A survey was taken of purchases at the crossroads. So open the file and use the data to answer the next 3 questions. Let me find this in my homework. So now I have it in here. Can't find which page it's on. Oh, right there. Okay, and then it's using software, calculate the mean of the amount spent, and I got 4.771.
Okay.
That's what I got.
Yep, that's what I get too.
And I don't know, since it's money, I don't know why we round it to 3 decimals, but whatever.
Right?
I think the same thing in percents and everything. Like, why aren't we rounding it? But whatever.
Okay,
Yeah.
4771.
Yep.
Okay.
Does it tell you the quiz what you're on?
Says round to 3 decimals.
So I believe I have question 9, if I'm not mistaken.
Yeah.
Okay.
So it says using software, calculate the standard deviation of the amount spent. And I got, and rounding to the 3 decimal places, I get 1.912.
Yep, that's what I get. 1.912. Is that what you said?
Yep, that's what I said.
And then number 10, you just have to mark true or false if you made the histogram.
Oh.
Yeah, that's kind of weird.
So hopefully that's true.
Yeah.
You got an easy one, Melissa.
I can do
I created a histogram.
I can do the next one too if you want. I don't really care.
Go ahead.
Okay. Jessica Meir and her research team measured the body temperatures of a sample of diving elephant seals. A thermistor was placed at a specific location on each seal to measure its body temperature. The body temperature of seals tends to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initiate a dive and called this the representative temperature of the seal. Thermistors were placed at the hepatic sinus of 4 of the seals. The seal's body temperature at the start of the dive was calculated to be, and it lists the different temperatures for the 4 seals. Complete the following table and use your work to answer the next 4 questions. So what is the value that goes into position marked with an A in the table above? I don't know if I did this one right, but I got 0.228.
I got a different answer, but
I have a different answer too.
I didn't think I did that one right. So I didn't go through and do the whole mean. And so that's why I'm like, is it, sometimes I'm not sure if it's simple or if I have to go through and find the exact mean. So I hadn't done that on that one.
Okay, let's find the mean of the sample mean. So
Okay.
you're going to need to add the temperatures that are listed in the first chart together.
Right.
And then divide by 4.
And I did that.
And what'd you get?
Now I have to do it again.
Is that what you did, Heather and Allie?
So adding them together, I get
38.075.
Okay.
Yeah.
And I rounded because the temperatures, the representative temperatures are rounded to do 2 decimal places.
Oh,
So I
that's
kind
true.
of use that as my gauge. I rounded to 38.8. What did you use, Heather? 38.08.
I don't know if I got 38.14.
Sorry, I answered you, but I was on mute. So I kept mine at the 38.075.
Okay.
Just because, and then I rounded up at the end. So I don't know if that changes anything or not. So we'll see if we got similar answers, rounding before or after, but that's what I used was the 3 decimals.
So I don't know why originally I got the mean of 38.14. I must have entered something wrong. But so I got 38.075. And in some of the instructions throughout the lessons, it says don't round until the end. So I didn't round until the end. So I take 38.075 minus 37.91, and I got 0.165.
And it's a negative, right?
Yes.
Because I got it as a negative. Not that it matters in the next one where you square it, but for this answer, it's a negative.
You're right.
Okay.
And I always stress, because I've gotten some answers wrong, if I didn't put a 0 first. Does that happen to you guys?
Yes, always put that dumb 0. Okay, so without rounding, it's 0.165.
Yes, and it says 3 decimal places.
Yes, it does. That would be nice if that was in the instructions too, or the print.
Yeah.
So it's
okay, what is the value that is in B? And I'm going to recalculate that because I had rounded mine to 38.8, and so I'm going to use 38.075. And let's see if that alters that. So you're going to subtract 37.25 minus 38.075 squared. Can I use your phone? So, because I've got Allie on and I don't want to mess around with that.
No. It's really hard. No.
what are you looking for? A picture to color? You're looking for the picture. Okay, here's one you can color. Color a notebook. Okay?
Okay. I've got so I took 37.25 minus 38.075 squared, and I got 0.6806. What do we round to? 3 decimal places.
Yeah.
Okay, so it's going to be 38, or excuse me, 0.681. Did you all get that?
Mm-hmm.
Oh, darn, that's ugly. Hold on. I'm adding it into, I need to go down to the correct answer. I'm trying to type over another one I already answered. Okay.
Oh, yeah, that would be.
Depressing. I just realized that we have so many questions. It was only showing the first 12, and I was like, oh, there's only 12 questions on our quiz. Now I'm realizing there's a lot more. Okay, whose turn is it? Back to me.
It's yours, Ellie.
Sorry, I'm having a harder time keeping track today. Okay, what quantity is equal to the sum of the numbers in the square deviation column? And I put the variance. Is that correct?
Yes, I put the variance.
I put none as correct.
I put none as correct.
Okay.
Just because it didn't have the exact, because the variance has the n-1, so it's not just the sum, it's the sum divided by n minus 1. That's why I chose none.
Yeah, that's why I chose none too.
Oh, okay. That makes sense.
So the variance is the mean of 38.075 and the temperature that moves from that mean. So
The variance is the sum of this divided by n minus 1.
Yeah.
okay, so
That's still good.
does that make sense?
Yeah, I think so.
Okay. So yeah, the variance is what Heather was just saying, you know, and then you have to have n minus 1. So that's the variance. So do we agree that it's none is correct?
Yeah.
Yeah.
Okay.
Mm-hmm. Okay, so question 14 says, what is the standard deviation of these temperatures? And so I got, let's see, and it says to round to 3 decimals, so I got 0.715.
And I got 0.261. I don't know why I'm different.
So this is what I did to get the answer, is I took the variance. So you had to figure out the variance first. So then you take, so the variance, like we talked about, is the 1.533 divided by n minus 1, and the n is 4, because there are 4 seals. So then for that, then I got that as 0.511, and then the standard deviation is the square root of 0.511.
Oh, okay. That makes
Okay.
sense.
Yeah.
And I look back to the lesson to get that. Like, I didn't just pull that out of my head.
Yeah,
I look back to the chart that we did, and I think it might have been in lesson 3. I'm not. Yeah, it's in lesson 3. So
Okay.
the standard deviation, the formula for that is taking the S, or the variance. Yeah. Anyways, and it equals the square root of S squared. I don't know. Does that? I guess you just have to look at those formulas. Anyways, I don't know. Do you guys agree or disagree?
I agree. Allie, do you understand that you had to go in and you had to calculate each one of those seals to get their square deviations, and then you add those together? Did you get that?
I did that, yeah, and the sum was 1.534. Is that correct?
Right. And then
Okay.
divide that by 3.
Let's see.
Oh, okay. Yeah, and I did. Wait. Yeah, and my calculator's on my phone, so I can't really do it right now. But what does that equal out to be then?
Okay, and that gives you your sample variance, which is 0.511.
Mm-hmm.
Okay. Yeah, that's what I got.
Okay,
And then I thought you just squared that. And
yeah, then
No,
take
it's
the,
square root.
you have to take the square root. Don't square it. Take the square root.
Oh, that's what I did wrong. Okay, I squared it.
Yeah, because it was already squared. Those answers are already squared. So that's why you have to take the square root. Because in that third
Yeah,
column,
that makes
they're already
sense.
squared. So now you take the square root.
Okay, now,
That makes
yeah,
sense.
and then you're going to round. So you should get like 0.7148426, blah, blah, blah. And then round it to 3. So
what's the final answer then?
0.715.
Okay. Sorry, I thought someone said 3, so I was confused. Okay.
okay. Who did that one?
I did. Heather did.
Oh, okay.
Okay, I think I'm up. Question 15. Under certain conditions, the standard deviation can be negative, and I put false.
And that's
Yes,
what
I
I
chose
chose.
false.
Okay. All right, on to number 15. Using the same study with the sills, they placed the thermosaurs in 6 other sills in their aorta, the largest artery in the body. Finally, they placed thermosaurs in 4 other sills in their hepatic sinus, and I learned that that is their liver.
Oh, interesting.
I was thinking sinus as in, okay, here's that.
That's what I was thinking.
The liver, huh?
Of this study are summarized in the table below. Yes, because I'm sure you all wanted to know that.
I was wondering.
Which location resulted in the most consistent temperature? And the most consistent temperature was the extradural, and the reason you know that is because it had the smallest standard deviation.
Yeah,
And,
that's what I got.
okay, excellent.
So even though it was the smallest sample number, because I put extradural because it had the lowest standard deviation, but it doesn't ever matter if it's the sample size is smallest, or do you go off of standard deviation?
Well, since they're all relatively small, that's a really good question. Because think about the law of large numbers.
Yeah.
With the law of large numbers, your standard deviation gets closer to the mean, but these are all low. So even though, you know, one is 6, I think, and one is 4, those are still really low. So then you're going to look at the standard deviation, and extradural had the smallest standard deviation. So that tells you that the data points were closer together.
Okay. That's what I thought. Does anyone know who's up?
It's you, Allie.
I should keep up. I'm sorry.
That's okay.
Okay. Let's see. It's the box plot. About studying for an exam. The question 17. What is the third quartile? And I don't know what I did wrong here. I have a minimum, a first quartile, a median, and a second quartile, and a maximum. What did I do wrong?
Well, let's see. I don't even think it asked us what the third quartile was in the question. So shall we go over what each quartile was according to the
That would be great, because did I get mixed up by having a minimum, a first, a median, a second, and a maximum? That's
No.
not correct.
No, because that was the answer to number 18.
Yes, it asked that question, so that's
Yeah.
fine. Okay, so I had to go back and read the lesson on box plot. And in the 5-number summary, what did you all have? I had 2, 4, 6, 8, and 12.
Yes.
Yeah, me too.
Okay,
Yep.
so the median
Is
on the
6.
box plot, the median is, as Melissa just said, it's 6. And then
Yeah.
your quartile 1 and quartile 3 are trapped within that box.
Mm-hmm.
So quartile 1 is
4.
4, and then quartile 3 is,
Oh, it's 8. Yeah, I just wrote down second quartile. I needed to review that again.
okay,
So there's
yeah,
just a minimum, a first quartile, a median, a third quartile, and then a maximum, right?
yeah. And that, I was confused on that same thing. Well, what happened to the second quartile? And
Yeah.
so I had to go back and review that. So,
Okay. That makes sense.
then that gives us the answer to number 17, which is,
So the answer is 8, correct?
8. Okay, so number 18 says, what percentage of the data lies between 4 hours and 8 hours? List the number as a percent, not a decimal, and don't include the percent sign. So if the answer is 66%, input 66, not 0.66. So the answer I got is 50.
yeah, that's what I have.
Yeah.
Okay.
And you don't put a percent sign, do you? You just put 50?
Just put
Yeah,
50, 50.
Okay.
Yeah.
Okay.
Okay, 19. An observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52 parts per million, and values outside of this range are unusual. We will assume that mean minus 2, what is that? Variance, not variance.
Standard
I
deviation.
just read it, standard deviations. So the mean minus 2 standard deviations is 1.59 parts per million, and the mean plus 2 standard deviations is 2.52 parts per million. It is reasonable to assume the measured nitrate concentration is normally distributed. So estimate the mean of the measured nitrate concentration in the Rexburg drinking water. Okay, so what I did was I took 2.52 minus 1.59, which gives me, and then I divided that by 4. So that should give me the standard deviation. And so if I add 2 standard deviations to 1.59, I get 1.822, 1.823. And that's the mean.
Okay.
Does that make sense at all?
I got a different answer, but
Yeah, I do too.
I have to figure
All right,
out
what do you guys
how
have?
you did it.
Okay.
I got
Yeah.
2.06.
Okay.
And
That's,
I
What did
have,
I do wrong there?
I have 2.055.
yeah, that's the one I
Did I
got
just
was
add it wrong?
2.055.
Ah, I got 2. Okay, 2.055. Yep.
Okay, Melissa, what I did and we did differently is you said you divided by 4 and I divided by 2.
Why would you divide by 2? I guess that would just give you half of it, so that would make sense.
Yeah, so because you're going 2 standard deviations from the mean.
Sure.
So
Yeah.
if you take 2.52 and subtract out 1.59, it gives you 0.93, or it's probably not 0.93 because I was rounding to the second decimal place.
No, that's good. I don't know why originally I got 1.82, but anyway, I recalculated 2.055.
Okay. Does that make sense?
Yeah, it does.
Okay.
And I wrote down 2.06 originally, so I wonder if that's going to mess up the rest of my calculation.
It probably will, but that's okay.
Because it says round to 3 decimal places, so just watch out for that.
Yeah, I need to do that.
I did that on the one with the whales or the seals.
Oh, I know why I divided it by 4. Was because the next question says, what's the standard deviation?
Yeah,
I think
what's a standard deviation from of the measured nitrate levels? So it is 0.23. It's going to be 0.233 is what I have. So 0.23. Is that what you all got?
Yeah.
Yeah, that is what I got.
And that's a plus or minus.
Yes.
So, but I don't think we have to put that in.
No.
So
Yeah, because it can
How I
go.
got it. That's the answer I got, but what did I do? Just so I remember.
you, okay, once you did the
Oh, I know what I
2.52,
did. Yeah, so I had 0.93, then you get half of that, which is 0.465,
and then take
and
half
then
of
you
it.
divide by 2,
Correct.
because it's 2 deviations away. Is that right? Okay.
Yep.
Okay, good. All right. are we back to?
We are back to, let's see, I just went, so it's your turn.
Okay. Let's see. Between what two measured nitrate concentrations do approximately 68% of the data values lie? And I wrote down the wrong answer, I can tell already.
Is that because you rounded down to 2.06?
Yeah, I can tell that I did it wrong. So let me, let's see. 58%. So if the standard deviation is 0.233, then we need to add 0.233 to both. Let's see. Yeah. Subtract it from one and add it to the other.
Yeah, you're going to add and subtract from your mean.
Oh, what did you find? Oh, cute.
And sorry, I have to use my phone to use my calculator. Just a second. It would be the last answer, the 1.823 and 2.288.
Yep.
Yep.
Okay. Sorry it took me so long to get that.
That's okay.
Yeah, that's what I get too. Okay, so the next one says the admissions committees for most Masters of Business programs require the graduate management admission test as part of the application for new students. It has been shown that the scores on the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission to the MAC program in the School of Accountancy at BYU is 500, but it is rare for students with scores less than 600 to be admitted. What is the probability that a randomly selected student will score above 542.3 on the GMAT? And let's see where. So actually on this one, this is one that I did not know how to answer. I have it like red flagged, so it's awesome that I got it. Because normally I would think you would take the 542.3 and subtract it from the mean, but I just got 0, and I didn't think that could possibly be the answer.
Okay, well, let me...
I put 50 because if it was the mean, then 50% are above and 50 are below. Is that correct?
That's what I have.
Oh,
Right.
well,
And
let's see.
you know why? Okay, so Heather, you got it right because it's 0 is our numerator on that equation, and if you put it in the normal probability applet, and you put 0 as your z-score and only shade the right side, it's 50%.
Oh,
That's how that works.
okay.
Yeah.
So I just didn't trust myself on that one. So
Because you got the right z-score.
Do we put in 0.5 or 0.50?
well, last time they had us put in 50.
Ooh,
I never remember when it's probability. Is it point or is it just the number?
That's right. It is 0.5. It would be 0.5.
Just 0.5?
I'm going to put 0.50.
I'm going to put 0.50 too.
Okay.
So let's all put 0.50.
That's what I did.
We'll see what happens.
Yeah.
Okay. Hey, can I ask you both a question? Because in our homework, it skipped over one then on our quiz. So in the homework that we did, number 23, what did you guys get on that one?
Oh.
I think that's Vicky. She explained it before.
We determined that was just a standalone question in there. to define the mean and the standard deviation of a normal distribution. So mean is 0 and standard deviation is 1. On a normal distribution, mean is always 0, a standard deviation is always 1.
Got it. Okay.
And that's on a standard normal distribution.
Okay. And that's always. Okay.
Yeah.
Always normal.
And
okay.
that was,
Sorry, thank you for going over that.
yeah, that's just a definition. That is a straight up definition. And what lesson was that off of? I actually had written that down. But anyway, that's just a straight up, that was just a definition. And I don't know why it was randomly stuck in there. It's kind of weird.
All right. Appreciate it.
Okay, question 23. What is the probability that a randomly selected student will score below 600 on the GMAT? So 600 minus 542.3 divided by 120.54 gives me a z-score of 0.479. So I put that in my probability applet, and I get that the probability they'll score below that, 0.316. Now that I think,
I got it. I got
No,
something different.
Okay.
because wouldn't it be shading both? Because I think I only shaded the left side, but shouldn't I shade the middle and the left?
That's
So
what
then I
did.
get 0.684.
Yes. Okay,
Yeah.
yeah, because it's the reverse.
Right. Yeah. Okay. So it's 0.684 if you shade both of them, which I think you're supposed to.
684. Yeah.
Why is that not saving? It must be that it's not saving any of those answers. Huh, that's weird. Did you see that? Yeah, it hasn't saved since number 15. Hold on a sec, guys. I've got a little computer issue here.
Yeah.
For some reason, my answers haven't been saving on my test, even though I'm clicking, and it's just not saving. It just brightened up, that's for sure. So maybe that's why. 15. Okay, all right. Let me see what number is it. Sorry guys, my test just froze up on me.
Oh no.
So
Oh,
probably.
Well, what's your right?
That happened to me last
I got them all written down. So let me. For some reason, it's not saving any of my answers. So we'll see when I get to the bottom if it was saved. Okay, so what number are we on?
24.
24. Okay, let me scroll down to that one. Okay, what is the probability that a randomly selected student will score 600 or above on the GMAT? Okay, now that was 0.316.
Right.
Yeah.
Because it's just the reverse side of the other question that you have, Melissa.
Yeah.
Okay, and then I am next. So question 25, find the GMAT score that corresponds to the 10th percentile. And that's where I did x minus the mean divided by the standard deviation. So I come up with 387.768. Oh, and it says round to the nearest whole number. So 388.
That's what I got.
That's what I got.
Perfect, yep.
Okay, and then the next question just wants you to find the GMAT score that corresponds to the 90th percentile. And so I got 696.83, so rounded up 697.
Yep.
Yep.
Okay, and I have not done this one yet, which is mine. Find the first quartile for the distribution of GMAT scores. So do we have to make a box plot, or can we just go like one standard deviation from the mean?
I had the exact same question. On our homework, I didn't do this one or the next one because I didn't know exactly how to get them.
Shouldn't it be
So
just
you guys
one?
that did it, what did you do?
I'm looking to see it. And I think you're right when you say that you probably do just do a box plot. Because what I did was I put it in the applet, put in the like 0.25 and found the z-score, but I'm not sure that that really works now that I think about it.
It absolutely works.
Does it?
Yeah.
0.25?
Explain to me what you did again because I'm not sure. I'm sorry. It's a little hard.
So
Hey,
I went. Oh, go ahead, Vicki.
I thought she was, I wasn't sure who she was talking to. You go ahead, Heather.
Well, so I went to the applet, and up at the top where you can put in the area, I put in 0.25, and then I shaded the left-hand side and got a z-score of 0.674. Is that what you got, Vicki?
That's exactly what I got, 0.674.
And then I plugged it into the formula that we were just using for the last two. And so I got an answer of, okay, now what? Let me see if I did my math right. Okay, so I was confused on this one, whether you use the negative 0.674 or the positive.
I think
for the
mine is
z-score.
negative.
What's that?
I just put it straight in as 0.674.
So use the positive one?
Yeah.
Because then that would give you, but see, the answer I got doesn't really make sense to me. Okay.
What you did, I got 461.0.
That's what I
Okay. Yeah, that's what I got, but okay, so
now,
maybe it does
now
make
think
sense.
about this. If the mean is 542.3 and you want the first quartile, does 461 for a score sound reasonable?
Yes.
Yes, it does. Because the one standard deviation away is 120.
Which is close.
Yeah, which is close.
Mm-hmm.
So that is reasonable. My husband taught me to think about those as being reasonable. So when we do those, to look at them and then go, okay, does that look reasonable or sound reasonable? So.
Okay, that's good. That makes sense.
Okay. Just so I understand what's going on. I'm sorry, it's a little hard for me to understand the conversation that's going on. So I put it in the applet as 0.25, and I got the z-score of 0.674. But then how did you guys come up with the number? That's where I got lost.
Okay. So you plug it into the formula. I can show you my paper, but it's like x minus the mean over the standard deviation equals the z-score. So you can do it backwards by taking the z-score from the applet and work backward.
That's true. I always forget that. Okay, that makes sense.
Okay, so even though that one was supposed to be mine, can I say, so 28, so I worked it the opposite way with the third quartile, and I get 624. Is that right?
For the third quartile? Yes.
Yes, question
Okay.
28.
I have a question. Can I back up? You guys put in 461, right?
Mm-hmm.
Okay. I just want
So
to make
461 on question 27, right?
Yes.
Yes.
Okay. And then 624 on question 28.
Say
I don't know.
again.
I got 623, but I'm not sure if I just rounded differently.
I got 623.54. So if we round to a whole number, then it would be 624.
I got the same as Vicky, so that's
Okay.
how I
So
rounded.
that's, yeah, I just didn't round yet then. 624.
Okay. Did you just go, Vicky?
No, it's my turn. Number 29. Consider a simple random sample of n equals 15 students taking the GMAT. What is the mean of the distribution of sample mean scores for all such samples?
Okay.
Okay. What is the mean of the distribution? The mean is 542.3. The mean is the same as the mean of the original, so it's 542.3.
That one always throws me when they ask that.
542.2. Okay. These ones I didn't get either. I was super confused, so that makes sense. So then on question 30 is me. So what is the standard deviation of the distribution of sample mean scores for all such samples? Ooh, and I didn't get this one because I didn't know the mean yet. So, so would the standard deviation be the same also?
Well, you need to find the standard deviation for the sample. So use your formula of taking the standard deviation of the population and divide it by the number.
Okay. And I'm sorry, I didn't have this one done, so it's taking me a minute. So help me remember what formula I used for it.
Okay, the standard, the formula for figuring out your standard deviation for a sample is taking the standard deviation of the population, and in this case it's 120.54, and you're going to divide it by the number. And the number we're working with from the sample is 15. Oh, excuse me, the square root of the number. Let me not leave that out.
Okay.
So you're going to divide 120.54 by the square root of 15.
Right?
Okay. Just a minute, let me do it on my phone.
That is so weird.
Okay, so 31.124. Is that correct?
That's what I get.
Yep.
Okay.
Okay, one more.
Okay,
Woo-hoo!
last question. What is the probability that the sample mean GMAT score for an SRS of n equals 15 students will be greater than 600? And so you have to go through a bunch of, you have to do the formula that is the, so you take 600 minus 542.3 and divide it by 120.54 divided by the square root of 15. So going through all that math, I got 0.0319. Or if we do it to the 3 decimal places, 0.032.
Yep.
That's what I got.
So 0.032 is what I'm typing in.
Yeah, that's what I got. So you took your z-score and you plugged it in and boom, got that probability.
Yep, went through all that dividing and fun math. Now we'll see what we get, guys.
I'm scared.
Now, Vicki, is yours able to save at this point? Because if not, we can go through and read you the answers again.
Oh, I still see my whole test, and I can scroll through the test. I can enter the answer in. When I hit the save button, it's not saving. And no, I just tried hitting save all responses, and it's not doing anything.
Oh,
but
shoot.
My answers are all still there, so I'll just go in and.
Well, if you put the same, then it should be 100% as long as it keeps all your scores.
You get
Wow,
100?
ladies. Yeah,
Yes,
that is
good
awesome.
job, ladies. That's amazing.
Awesome.
A painful hour, but worth it, right?
Yeah, very true.
Just kidding.
Okay.
It was a little painful. You're right.
Okay. Do you all feel comfortable about the test? I'm going to try to do mine tonight because
Right away,
we go right on to lesson 9, and we meet Wednesday morning. I can't wait until tomorrow. Otherwise I'll get new stuff confused in my brain. So
yeah, I better do
gonna
it while I'm
take my
thinking
exam.
of it.
Yeah. You
That's
guys have
good.
any questions on anything?
Oh, I feel better now.
The only one I had a question on was that last question, which equation you used for it. Did you use the really long one where you have to do all the different calculations on it?
Are you hearing Allie's question?
Yeah, so she's asking what formula we used on the very last question.
Yeah.
So I use the one that is just like finding the z-score. The only difference is on the bottom half, you take the standard deviation and divide it by the square root of the sample, which is the square root of 15. Or if it's just a formula, it looks like the square root of n. So the standard deviation divided by the square root of n is on the bottom, and then the top is the normal, the x minus the mean.
And
Okay, perfect.
Allie, how I differentiate between the two is on my formulas, I have z-score formula for the population because sometimes we have to figure out the z-score for a population. And then I have sample z-score.
Mm-hmm.
So that I know, oh, okay, I'm dealing with a sample. In this case, it's 15 students. So I know I'm going to use the formula for the sample z-score, not the formula for the regular population z-score. That's how I keep the two straight.
That's good. I'm going to call them that because I wrote mine out like you had a list.
Uh-huh.
I just am still getting confused as when to use which one. So that makes sense. If it's ever about a sample, you do the longer one. So.
Yeah.
Okay.
Yeah.
All right. Thanks for letting me call in today.
Thank you, ladies.
I'm glad you called. I don't know what the deal was. That's really weird. But they could.
I don't know. It might have to do with just being on a different computer. Hopefully when I'm home and I have my own computer charged again, it'll work right up on Wednesday.
Maybe so.
Yes. So Vicki, just remember that you have to hit stop broadcast and then take the link from the
And
so
the link, is that what's at the top where it says Google Hangouts and it's got a huge long number and whatnot?
No. So if you hit stop broadcast,
Uh-huh.
so if you hit that and then off to, I believe it's on the right-hand side, it will have a thing that says link or it has the link symbol and you click on that
Okay.
and it will give you the link. Do you see it?
Not yet, but if I hit stop broadcast, then I can't hear you anymore, can I?
Yes, you can. It
Oh,
just
okay.
isn't recording anymore.
Okay,
Right.
here we go. I'm stopping broadcast then.
Okay.
Good job, ladies.
Yes,
Good
awesome.
luck.